So in this video we're going to define and calculate a gradient of a function of two variables. So we define the gradient of the function f of xy as the vectored value function that we get when we take the partial derivative with respect to x and we make that the x component of the vector, and we calculate the partial derivative with respect to y and we make that the y component of the vector. And the notation for the gradient of a function is going to be grad f, or grad f of xy, or the gradient of f is also use the delta symbol, so you say del f. So grad f or del f are synonyms, and they both mean the gradient of the function f of xy, which is just which just has x and y components that are the partial derivatives with respect to x and y. So if I have a function here, f of xy equals x squared natural log of x plus x squared y squared, I can find the gradient of it at a specific value of x and y. So here it says find the gradient of the function when the ordered pair xy is the ordered pair 1, 2. So I'm going to need to calculate the partial derivative with respect to x, and the partial derivative of with respect to x of x squared times the natural log of x, I'll need to use the product rule on that. So I'll get 2 times x times the natural log of x plus x squared times the derivative of the natural log is 1 over x, plus I have x squared times y squared, so y squared we're going to hold that as a constant coefficient on x squared when we take the derivative with respect to x. So we're going to get 2 from the exponent coming down, 2 times y squared times x, and we can simplify this just a hair. It's 2x ln of x plus x squared over x is equal to x as long as x isn't equal to 0, and we get plus 2y squared x. And then the partial derivative with respect to y, the partial derivative of x squared natural log of x is 0 with respect to y because the x terms are constant. So we're going to get 2x squared y, 2x squared y. So del f, or the gradient of f in general as a function of any x and y input, is going to be the vector that has f sub x, or the partial derivative with respect to x, as the x component. So we would have 2x natural log of x plus 2y squared times x, comma, and then the y component would be the partial derivative with respect to y, which is 2x squared y. This would be the gradient in general. But if we're being asked for a specific value, specific gradient, so gradient for a specific ordered pair 1, 2, we could just plug 1, 2 into the two terms. So I'm going to kill this guy real quickly. So the specific gradient we're being asked for requires us to evaluate the partial derivative with respect to x at 1, 2. So we just step and plug in our values. 2 times 1 times the natural log of 1 plus 1 plus 2 times 2 squared times 1. But the natural log of 1 is 0, so that term gets killed. So we get 1 plus 2 squared is 4 times 2 is 8. And we get 9. And over here we need to calculate the partial derivative with respect to y when x is 1 and y is 2. So we're going to plug in 2 times 1 squared times 2 is just going to be equal to 4. So the specific gradient that we're interested in del f when x is 1 and y is 2. And that gradient vector is going to be the vector, the partial derivative with respect to x when x is 1 and y is 2 is 9. And the partial derivative of y when x is 1 and y is 2 is just 4. So this is the specific gradient that we were asked to find. Again, we can find the general gradient vector by just plugging the f sub x and the f sub y into our vector.